It's Mr. Allen Math time. We're going to find the area of the regular hexagon with a perimeter of 72 inches. All right, so we have a regular hexagon. Do we know our formula for the area of a regular polygon? If not, let's jot that down. It is 1/2 multiplied by our apothem, what the heck is that, times the perimeter. The perimeter is our distance around, and we already have that. So I like to do this. Perimeter 72. Apothem, I don't know. And let's also remember, what is the apothem? The apothem is the distance from the center of this regular polygon to the edge right there and perpendicular to that edge. This is my apothem. We need to figure that out in order to plug it into our formula. So let's figure that out. Shall we? I think we shall. Well, if my perimeter is 72 inches and I have a hexagon, I can take that 72 and I can divide it by the 6 sides that I have here, right? And I'll get 12, which means that each one of my side lengths is going to be 12. So I've got a side here. Now, what if I were to draw on some radii here and create some kind of a triangle, okay? Because triangles generally help us solve things. Triangles and rectangles are like our most basic shapes. We tend to use them quite frequently. Well, let's see here. I've got this central angle going on right here. Okay, I'm going to do the whole thing there, going across that apothem. How many central angles are there in a regular hexagon? There are 6. Okay, so if I were to take the 360 degrees in a circle, right, because these regular polygons can be inscribed in a circle, I take that 360, divide it by the number of central angles or the number of sides, which is 6, and I'll get 60 degrees for that entire central angle. So what's that going to mean for just a portion of it? Well, that's going to get cut in half by the apothem and make that 30 degrees. So I have a 30 degree angle. I have a 90 degree angle. That's going to leave me with then a 60 degree down here because 180 degrees in a triangle. And now I'm dealing with a 30, 60, 90 triangle. We're looking at that one side being 12. What's that apothem going to do to that side? It's going to split it in half and give me 6. I think we should draw this triangle off to the side now. So we got my triangle there outlined in green and then off to the side for some work. So I have the side that is across from my 30 degree angle, okay? That's the nice one to work with, right? Because I can either multiply by root 3 to get the one that's across from the 60, so that'd be 6 root 3, or I can double it to get my hypotenuse, which I don't care about here. All I wanted was the 6 root 3. That is my apothem right there. So we've got the 6 root 3. I can just plug this thing into my formula. So let's do that. Area is equal to 1/2 multiplied by my apothem, which is 6 root 3, not 6 root 6. Multiplied by my perimeter, which was given to me in 72. And now I can go ahead and do some math. All right, I'm going to cut the 6 here in half and make that 3 root 3 times 72. Now I'm going to try and do some mental math, okay? 3 times 70 is 210, so 3 times 70 is 210. And then 3 times 2 is 6, so that'd be 216 if I were to multiply the 3 and the 72. So that means that I'm going to end up with 216 root 3. That root 3 just stays root 3. I was only working with this 3 and that 72 to do those mental math calculations. Plug that bad boy into your TI-84 Plus, which you're always strapped with. I'm always strapped with that, but I like to do some mental math. So we get 216 root 3 inches squared. Boom. If we wanted an approximation, a decimal, I could plug that into my TI-84 Plus graphing calculator and get a decimal equivalent. But most questions are going to ask you for reduced radical, simplified fractions, no decimals, exact answer. We found the area of that regular hexagon. That was dope.